Data quality indicators. These are indicators of the quality of your data. So first you've got precision, and we've discussed that. That's the inherent uncertainty of your measurement method, that try as hard as you might, you can't eliminate completely. There is bias, and bias is a consistent, systematic difference between what your measurements are telling you and what reality is. So generally, that's a calibration error. That's bias, is the second data quality indicator. The third data quality indicator is representativeness. And this is one of the two non-numeric data quality indicators. So representativeness means mostly that you've done your homework in terms of deciding where to make measurements and when to make measurements to ensure that your measurements are representative of the population that you're concerned about. The fourth data quality indicator is detection limit, and that basically is how low can you reliably make measurements that you can distinguish from zero with this equipment, and is this adequate for the goals of your project? In other words, you want to make sure that if you're interested in low concentrations, you pick measurement methods that really can measure reliably at low concentrations. That's detection limit. The fifth data quality indicator is completeness. That's basically how many measurement results are valid compared to how many measurement results you plan to make. 75% is the requirement for completeness. If you're making measurements to compare against the National Ambient Air Quality Standards, you may want to have as a goal 90% completeness, but 75% is the minimum to make conclusions about attainment or non-attainment. The next data quality indicator is the second non-numeric data quality indicator, and that's comparability. You want to make sure that when you compare your data with other people's, you're comparing apples and apples. So the big idea for comparability is that you use similar procedures. So when you make a measurement with this particular piece of equipment, you've researched how other people use this equipment. You've gone online and looked up our online data library for SOPs for people using this or similar equipment to make sure that when you use it to generate numbers, those numbers are comparable with theirs. And of course, following a similar QC system and QC limits is very important for comparability. And then the last data quality indicator is accuracy. And accuracy combines both imprecision and bias. And accuracy is really only estimated when you call in an outside auditor, or at the very least equipment that wasn't calibrated against the same primary standard that your equipment was calibrated with, so that you can do a truly independent assessment of the numbers that your equipment is telling you against another piece of equipment that was calibrated against a different primary standard. That's really the only way to estimate accuracy or total error. And each one of these 7 data quality indicators has to be addressed in your QAPP. They have to be defined, and you have to say what your limits are for them in order to generate data that will meet the objectives for what you want to use your data for.